Good morning. Today I would like to teach a very important concept of mod functions. Mod functions is a very important topic, particularly for joint entrance and as well as board. And students have also problems to conceptualize it and apply it. It is being used not only in class 11 but also it is being used also in class 12 in continuity and differentiability, in differentiations, in integrations, in everywhere. That's why we have to know that what is a mod functions. All of us know from class 7, 8 onwards, the basic mod function concept is that this is the mod operations, and under this mod operation, if I write mod minus 5, this is always 5. If I write mod minus 3, this will produce 3. So the mod operation is basically represents that if it always produce a positive value. So our objective is today that if it is a mod functions, if we can take a mod functions and if we write that f of x y is equal to f of x is equal to mod x. What does it mean? All of us know that if I write y is equal to x, this is actually also called a 45-degree line. Let us understand this first graphically. Y is equal to x. If I plot this value, x is equal to 1. Suppose this is x axis, this is y axis. This is x is equal to 1, 2, 3, 4. This is 1, 2, 3, and 4. And here also minus 1, minus 2, minus 1, minus 2, etc. So if y is equal to x, if we want to plot it, we plot this value and also minus 4x is equal to minus 1, it is minus 1. And we join this, then we can get this straight line, and this straight line implies y is equal to x. Here, for any real values of x, that is the corresponding values of y, and that can be positive or negative. But once I write mod functions, we cannot draw like this. And that's why we have to know that what is a mod functions, and our objective is to convert this mod function into piece functions. So what we understand, if simply mod x is written, you can think for a number line like the previous one, and for simply x I can get the critical values is 0. This is called the critical values. To the right side of 0, all the x values are positive, and to the left side of 0, all the x values are negative. And what will happen that following this, suppose x is equal to 1, if I put over here, then corresponding values should be 1 following the previous one. Suppose this is 1. If x is equal to 1, that is 2. And if I join this, I get this graph. Now, for x is equal to minus 1, again the y value should be 1. because it's mod. Because mod of minus 1 is equal to 1. mod of minus 2 is equal to 2. Mod of minus 3 is equal to 3. So mod of minus 1 we can get this point. Mod of minus 2 we can get this point. Mod of minus 3 we can get this point. And if I join this, our line we can get 45 line, which is actually passing through the second quadrant. So this two graph conjugately implies this mod function f of x is equal to mod x. This is how graphically you can understand these mod functions. Now, other than graphically also, we have to understand these mod functions into piece functions. It is very important. Now, what is piece function? Piece function means when the functions are represented piecewise for different domains of real numbers. X has so many domains, and for different domains the functions are splitted. Okay, so that is called piece functions. For example, here as we saw, for any positive values of x, y value is always positive. So we can say that y is equal to x for these cases when x is greater than 0. Now, if x is equal to negative values, if x takes the negative values, minus 1, minus 2, minus 3, minus 1.5, the corresponding values of y also positive because of mod functions. Say y is equal to mod minus 1 is equal to 1. So we can say that y is equal to minus, if I write minus x over here, x is negative. Put x is equal to negative, minus 1, minus of minus 1 is equal to 1. Put x is equal to minus 2, minus of minus 2 is equal to 2. Put x is equal to minus 3, minus of minus 3 is equal to 3. So the values of y always produce a positive value. Whatever the values, positivity or negative value of x, the y value always positive and equal because of these functions. And that's why this is called piece functions. So these functions we can also represent in this way, that f of x is equal to x when x positive, 0 when x is equal to 0, minus x when x is negative. And in this way we can represent these mod functions. Now this is simple mod functions. If we think about little bit difficult, students are unable to transform then the mod function into piece functions. Let us see. Suppose I can take one mod function as f of x is equal to mod x minus 2. Here I don't want to go for graph. I want to understand how to convert this mod function into piece function. That is very important. Now, how to convert this mod function into piece functions? That, like the previous one, I can write that, I can draw a normal line again, and here my critical value will be x minus 3 is equal to 0, and therefore x is equal to 3. So 3 is your critical values, and here suppose you write this is your 3, and to the right side of 3, all the x values are positive. That is more than 3, positive 3. And to the left side, it is 2, 1, 0, minus 1, here it is 2, here it is 1, here it is 0, minus 1. For any values of x, you can see y value is still positive. Let us check, suppose y is equal to 4. If I write over here y is equal to 4, which is positive, and more than 3, y is equal to 1. If I put y, so x is equal to 4, you can get y is equal to 1. So you can, if I write x is equal to 5, again y is equal to 2, and it is also positive. So these expressions, you can see that f of x, for this case we can write f of x is equal to x minus 3. Here I can write plus x minus 3 if x minus 3 is greater than 0. and hence we can write x greater than 3. So if the values of x is more than 3, I can write easily f of x is equal to plus x minus 3. Put any values of x over here more than 3, you can get always the values of f of x is positive. Similarly, f of x is equal to, I can write minus x minus 3, and that is obviously 3 minus x if x minus 3 negative. In this way, you break it x minus 3 minus x minus 3 if x minus 3 because negative negative positive. Here positive positive positive. So negative negative positive. Therefore, x minus 3 negative, that is x is less than 3. So what are the values? Say x is equal to 2. Put it over here 2 minus 3. Mod y is equal to 1. Put y is equal to 2. Y is equal to mod minus 1, that is 1. Positive. Y is equal to 0 you put. Y is equal to minus 3, that is 3. So we can break this mod x minus 3 into this manner. F of x is equal to minus x minus 3. That is 3 minus x if x minus 3 negative. And definitely f of x, if you put x is equal to 0, 0 is a factor, x minus 3 will be 0 if x is equal to 3. So you can say that f of x is equal to 0 if x is equal to 3. This is our target, and we have to know that what is the value of x is equal to 3. Critical value, around the critical values, we have to know these corresponding values of f of x, so that we can draw the graph. If we plot this graph, it will be a very interesting graph. For example, even if we can develop this as a piece function, so we can write in this way. These are gentleman's formations in piece functions. That is, f of x is equal to x minus 3 when x is more than 3. This is 0 when x is equal to 3, and this is 3 minus x when x is less than 3. Now, if you want to plot this graphically, say x is equal to 0, y is equal to 0. So this is basically here. Now, x is more than 3. When x is more than 3, then here 4, suppose 4, y is equal to 1. Suppose this is 1. If y is equal, x is equal to 5, y is equal to 2. So here we can line, not at the origin. Now, if x less than 3, say 2, 1, 0, minus, whatever may be, if you put 2 minus 1, that is positive, you can get 1. If you put 1 is equal to minus 3, positive 2. So naturally, if we join this, we can get. So y is equal to mod x minus 3 will like this, and that intersects at that. That's why 3 will be your critical value. This is your piece function, how to develop, and this is your graph. Now, next is a little bit difficult on mod functions. Suppose mod functions are expressed in this way. F of x is equal to mod of x minus 1 plus mod of x minus 2. Whenever these type of functions are given to you, your first job will be to break this into the piece functions. Now, how to develop the piece functions? Same thing, but I am showing you. First, to draw a number line and write the critical values. What is the critical values over here? X minus 1, from here you write x minus 1 is equal to 0, and therefore x is equal to 1. So 1 is your number 1 critical value. Here is 1 from left side. Similarly, x minus 2 is equal to 0. These are the zeros of the polynomial, and therefore x is equal to 2. So here again you can write this 2. This 2 is also second your critical values. Now, once we get, suppose 2 is over here. Once you get it, so for such little bit complex of mod functions, what you can do, see from, if I write a tick mark, this means from 2 to infinity, this is for plus infinity, this is your, in the number line, negative infinity. This means the values of x is more than 2. The values of x is more than 2 means what? Values of x is 2 means x minus 2 is positive. And x minus 2, if values of x is more than 2, values of x is also more than 1. So both these x minus 1 and x minus 2, both are positive. So we can, for this interval 2 to infinity, we can say the your f of x can be x minus 1 and x minus 2. Because if x minus 1 positive and x minus 2 positive, both this imply x is more than 1 and x is more than 2, and both this imply x is more than 2. X is more than 1, x is more than 2. So that means x is more than 2. My age is 50, your age is 30. So 50 is more than 30. Now my age is 50, your age is 20. So 50 also more than 20. If 50 is more than 20, 30, this means 50 also more than 20. It is easy to understand. So x is more than 2. So that actually produces 2x minus 3. And these functions basically represents in this zone. You can write this function also in this way. Under this interval 2 to infinity, the f of x is 2x minus 3. Now once I choose this one, it is very interesting. Here you see that the values of x, any value, 1.5, 1.2, 1.3, up to 2, whatever the values are there, all the values are more than 1. But those values are less than 2. That means, here if I want to develop this into piece function in this interval 1 to 2, I can say that x minus 1 has to be positive. But since the values of x is less than 2, here I can write x minus 1 minus x minus 2. Because if x minus 2 is negative, then x is less than 2. X is less than 2. So x minus 1 minus x plus 2 is cancelled, and this is 1. So within this interval, the function basically y is equal to 1. For any value, this is y is equal to 1. Now next is, if what happens if the real number values of x is left to the left side of 1, that is x is the values of x is less than 1, greater than infinity. What is this zone? It is interesting here. If I go back to the original functions, this happens if x minus 1 negative and x minus 2 also negative. So if x minus 1 negative and x minus 2 also negative, both these two imply x less than 1 and x less than 2, and that means x less than 1. Therefore, we can get this function as minus of, like the previous one, minus of x minus 1 minus of x minus 2, and that is minus x plus 1 minus x plus 2, that is 3 minus 2x. So this 3 minus 2x basically represents in these intervals for any values of x, which is actually, this means for any values of x which is in between 1 to infinity, say 0, you put this value 0, it is positive. You put 1, 3 minus 2, it is positive. So any values in between 1 to minus infinity, it always produce a positive values. And therefore, the piece function, if you want to write in the proper shape, after writing this, once I get this in the along the number line, you can write in this fashion the way I am writing. We can write that f of x is equal to 3 minus 2x if x is more than minus infinity and less than 1. This is equal to 1 if values of x is more than 1, equal to 1 and less than 2. F of x is equal to, we can write 2x minus 3 if values of x is more than equal to 2 and less than infinity. Here, just to see that x is more than equal to 1 and less than equal to infinity. Put the value over here, you can understand this. That if you put x is equal to 2, 2 to the 4 minus 3, 1. They also put x is equal to 1, is 1. Here, these three operations we can get the same expressions. I also can write using the set with minus infinity first bracket and to 1 in this way, and then x third bracket 1, this is 2, and then 2 to infinity. So in this way we can write these piece functions for mod x minus 1 plus mod x minus 2. And again, after drawing these piece functions, we can do so many things. From here we can go for continuity, from here we can go for integrations, from we can draw the diagram also. Already I have shown you. Suppose if I want to draw this diagram, if I am interested to draw this diagram, I can draw it in this way. Take any values which is less than 1, say 0. If you take 0 over here, we can get it put over here. That is y is equal to 3. Say 1, 2, 3 here. Say x is equal to this x is less than 1. Say x is equal to minus 5. By minus 5, then here you put minus 5, 10, 13. So naturally put over here and join it, and in this way we can get. And if in between 1 and 2, this is 1 and this is 2. In between this and this, values of y is always 1. That is like this. And in this way, we can get this graph if we plot it. Thank you very much. So, this is how we can work with the mod functions. If we can get mod x minus 1 plus mod x minus 2 plus mod x minus 3, the same way we can break the piece functions. Thank you very much. So today you have learned how to develop a mod function into piece functions.